could be the harm in paint flecks?
You're probably never going to see this particle coming at you because the closure speeds can be 50, 60,000 kilometers an hour.
We can detect an object like this orbiting overhead at a distance of roughly 1,000 miles.
I say it's like Russian roulette.
You get a runaway situation called a cascade.
It's only a matter of time before one of our space probes encounters some kind of space debris and spew plutonium on the planet Earth.
The chances of being actually hit by a piece of space debris are less than being hit by lightning.
My first instinct was that it was something from a shooting star.
Early in the morning of January the 27th, 1997, citizens of Georgetown, Texas, were awoken by an unusual noise.
My wife went out to get the newspaper. She said, "You better look out there, boy." She said, "There's something. There's a dead rhinoceros out here." Then I looked up at the sky. I said, "There's only one place it could have come down, is from heaven."
What had fallen from the sky to disturb the peace of this sleepy Texas community? The strange object which fell on Steve Gutowski's farm was fallout from an environmental disaster which is unfolding 1,000 miles above our heads. People have always been fascinated by what lies beyond our planet. During the past 40 years, science has turned dreams into reality. More than 4,000 rockets have been launched into orbit. Satellites and people have been thrust into space, and we have constructed marvelous new tools to peer deep into the heart of the universe. But we are now paying the price. Space is becoming a junkyard, littered with the smashed remains of rockets and spacecraft. A once virgin environment is being destroyed by pollution.
The total mass in Earth orbit that's been put up since Sputnik 1 is approximately 5,000 metric tons, and it's growing at a rate of almost 200 metric tons every single year.
And what we're now left with is junk. Millions of pieces orbiting our planet at speeds which turn a tiny screw into a satellite-smashing projectile. There is now so much junk orbiting in space that the larger pieces can be seen from the ground.
Six and a half, 7, 6.5, 6.
Astronomer Paul Malley has an unusual hobby. On clear nights, he turns his binoculars to the sky to record large pieces of junk which are orbiting or falling back to Earth.
Probably the most unusual and perhaps the most spectacular piece of debris was the re-entry of the shuttle's external fuel tank that I observed from Hawaii. This was in 1984. This object appeared above the edge of an extinct volcano and immediately began to break into dozens of pieces that just tumbled end over end and were flashing and flaring. And this whole ballet I was fortunate enough to videotape at the time, and it was probably the most spectacular piece of debris.
But most space junk remains in orbit for many years.
When the satellites have reached the end of their lifetime, they die, and some of them begin to rotate and spin. And every once in a while you can actually see one of these dead satellites that are spinning sort of out of control, and they will produce flashes that sometimes will be visible to the unaided eye.
The junk visible with a pair of binoculars is just a fraction of the pollution in space. The Liquid Mirror Telescope at Cloudcroft, New Mexico, is one of the few instruments which can reveal the extent of the problem. The reflector on the telescope is a spinning dish of liquid mercury.
NASA's interested in studying the population of orbital debris objects. They're interested in assessing the hazards to space station or space shuttle. And in order to do that, we need to count, have a general idea of what the population is of orbital debris objects. So we built a large telescope to see small pieces of debris. If you think about it in terms of what you can see with the unaided eye, the mirror is about 100,000 times larger than your eye, so it can collect 100,000 times as much light. There's a CCD camera on it, which is much more sensitive than your eye. It's about 10 times more sensitive. So overall, the telescope is about 1,000,000 times more sensitive than your eye, so you can see objects 1,000,000 times fainter. We're looking here at the field coming from the orbital debris camera mounted on the liquid mirror telescope. You can see lots of stars. And right here you see a very slow-moving piece of debris. That object may be 10,000 miles in altitude or so and about the size of a desk, as an example. Satellite that's tumbling. Either a satellite or an orbital debris object. Fast meteor with a contrail. Nice meteor with a very nice contrail, residual contrail. You could actually see it drifting in the ionospheric winds. There's a tumbling object, a satellite or a piece of debris. There's a faint one, and here's a tumbling, either a rocket body or a satellite. Note the high rate of tumble with a few specular reflections. So possibly a flat panel or some shiny surface that's catching the sunlight and reflecting it down to our eye. To give you an example of the types of orbiting debris objects that we can detect, this is a 2-centimeter ball bearing. We can detect an object like this orbiting overhead at a distance of roughly 1,000 miles.
There are over 100,000 objects bigger than that ball bearing, and many millions of smaller pieces orbiting near Earth. Traveling at around 20,000 miles an hour, each one is a hazardous projectile.
Orbital debris represents a significant hazard to space operations. The problem lies in the collision velocities of the orbital debris objects. As an example, a 1-centimeter marble traveling at a typical collision velocity of about 4.5 miles per second has the same kinetic energy as a car traveling at 60 miles an hour. So when even a small object hits something like a space shuttle or space station, it can have a significant and catastrophic effect. As an example, this is a 1.5-inch thick aluminum plate that was struck by this small disc, this small aluminum disc, traveling at roughly 2 miles per second. You can see the effect of that impact.
In 1983, the potential danger to humans in space was made plain when the Shuttle Challenger returned to Earth with a crack in its windshield.
Main gear touchdown.
NASA scientists found that it had been caused by a tiny fleck of paint which had peeled off another spacecraft. Avoiding debris is now a constant preoccupation of astronauts and mission controllers. Shuttle pilot Scott Horowitz has first-hand experience of dodging the junk.
If you're driving down the road, the way you avoid a collision is you see this other car and you just drive out of the way. Well, we can't do that in a spaceship. One, you're probably never going to see this particle coming at you because the closure speeds can be on the order of like 50, 60,000 kilometers an hour. I mean, you're just moving so fast.
I guess I could turn those. I'm going to take the DDUs in.
We get orbital debris impacts on the orbiter all the time, and we do a lot of different things to try to minimize the impact. So it's a concern, and we have a lot of ways to try to minimize the risk. You can change the attitude that the space shuttle flies in. Normally people think, well, it's like an airplane, it flies like an airplane, nose around the Earth, and that is one of the modes we fly in. But we have a whole group of engineers that do nothing but analyze the risk to orbital debris and the risk to the systems of the shuttle, and will change the alignment of the shuttle to sort of protect the critical systems, if you will, from orbital debris hits.
The astronaut describes the problem with professional calm, but outside his spacecraft, he is as exposed as a soldier on a battlefield. To minimize the damage and the risk to its crew, the shuttle now flies with its tail turned towards the most likely source of junk. So astronauts who have to perform essential tasks outside the craft are shielded by it to reduce the risk of being hit. Back on Earth, deep inside a hollowed-out mountain in Colorado, the American military tries to ensure that a catastrophe to a manned spaceflight does not occur. US Space Command has been able to warn astronauts in the Russian space station Mir when danger was approaching. On several occasions, Mir's crew have had to climb into their Soyuz escape capsule when orbiting debris passed close by. And Space Command also keeps NASA briefed about threats to the shuttle. NASA is warned if a visible piece of junk is likely to pass within 10 kilometers of the shuttle during the next 36 hours.
We tell the astronauts if debris is coming their way somewhat late in the game. As we get closer to a time where we actually need to make a decision about the maneuver and the object has hung in there and we think we're going to need to avoid it, that's when we get serious about the maneuver and notifying the crew and let them start factoring that into their plans.
When NASA's shuttle pilots had to dock with Mir, they found another kind of debris very close to their target.
One of the problems, specifically debris-related, is that the Russians tend to throw their garbage out the back door. And so when we're approaching Mir, we're kind of flying up through some of that.
Most space junk is not human waste, but bits of old rockets and satellites which have exploded and fallen apart. But some has been created by astronauts working in the difficult environment of space. Tools and large pieces of equipment have slid from their grasp or been thrown away. One astronaut lost a camera, others lost spanners. One of the most bizarre pieces of debris was a glove. It was lost by astronaut Ed White during the first American spacewalk in 1965.
The floating object in the foreground is the astronaut's overglove left behind in the spacecraft.
Until it finally fell back into the atmosphere, it floated free, waving aimlessly at the stars.
When you think of space debris, you think, what could be the harm in paint flecks, in little nuts and bolts orbiting outer space? Well, you have to realize that in order to attain orbit, according to Isaac Newton, you have to go at 18,000 miles per hour. That's an incredible velocity, many times the speed of a speeding bullet. And a paint fleck that hits you will go right through you. It will cause catastrophic rupture of our satellite probe. It'll cause them to tumble. Not only that, but the energy of impact goes as the square of the velocity. So in other words, if you double the velocity, the kinetic energy of impact goes up by a factor of 4. That's why, for example, when you get into a car accident at 15 miles per hour, it's just a fender bender. But when you get into a car accident at 30 miles per hour, you can do real damage. That's because even though the velocity doubled, the kinetic energy went up by a factor of 4. Now we're talking about debris traveling at 18,000 miles per hour. And if two come in at opposite angles, we're talking about a velocity for which no object will survive.
Orbiting in space, a bolt weighing just 3 grams has the same destructive force as a 1-ton safe dropped from 100 feet. At the University of Texas, scientists are using a high-speed gun to find out what happens when a satellite is hit by small objects in space. they are going to fire a plastic pellet at it at 5 miles per second.
Go in and take a look to see what we can find. The satellite, as you can see, has disappeared. This shows an example. This piece is still hot. This shows that satellite was made of about a 1/4 inch thick piece of aluminum. That's the entrance hole to it. This is a circuit board that has all of the components that are not destroyed by shock but are burned to a crisp. This is obviously a catastrophic failure of the satellite, and it would be very difficult to conceive of anything surviving and functioning after that kind of impact.
So how often do such accidents happen in space? Few have been witnessed, but there have been breakups for which there is no other apparent cause.
With our radars and telescopes, we can observe over 10,000 objects in space. Of those, we've seen at least 20 break up for unknown reasons, and we believe they are due to collisions between those objects and objects we can't track.
There's two reasons that debris has been accumulating in space. One is that people were not aware of what was going on, and secondly, there's no economic incentive not to leave something in space after you're through with it, because it costs a lot to bring it back down.
Rockets have been the only way of getting satellites into space, but the process produces tons of waste, and many of the discarded rocket stages still contain quantities of highly volatile fuel. They are time bombs waiting to explode and create yet more debris.
In a world of space-based weapons, there would be precious little time for humans to chat.
Far from reducing debris, space scientists have found ways of increasing it. The buildup of junk was accelerated by military experiments, as both the USA and the Soviet Union devised ways of disabling the other side's satellites.
Beginning in 1968 and extending through the early 1980s, the former Soviet Union conducted a series of anti-satellite tests in Earth orbit, in which the interceptor spacecraft would fire a charge with a large number of pellets in it, and during the process of that explosion, the spacecraft itself was damaged and fragmented and creating a lot of additional debris.
Over 40 years, we have been sowing the seeds of an environmental disaster, and the consequences are about to be reaped.
Possible breakup, sir.
12:36:47 seconds, 14-6 open, please.
Thank you. Thank you. It's a breakup.
Catalogue's reliable override.
David, it's Gary for knots. We've got a possible breakup on at this time. Okay, thank you very much.
As an object falls out of orbit and enters Earth's atmosphere, it breaks apart, and a cluster of traces appears on the screens of a radar station in northern England. In an isolated location on the Yorkshire moors, this is one of the most powerful radar installations in the world. Built during the Cold War to give early warning of missiles arriving from the Soviet Union, the array at RAF Fylingdales can detect objects over 3,000 miles out in space. The defense of the West is still Fylingdale's main function, but today it's space junk which presents the everyday problems. Orbiting junk could collide with military satellites and manned spacecraft. and large pieces of debris falling back into the Earth's atmosphere could easily be mistaken for incoming missiles. When something unexpected comes into view, it's immediately highlighted on the screens. The extraordinary power of the Fylingdales radar lies in these 7,680 microwave transmitters. With their combined power output of 2.5 million watts, any creature which strayed as close as this would be cooked within minutes. The vast 8-story pyramid has 3 faces probing 360 degrees out into space. It can pick out objects less than 10 centimeters across, over 3,000 miles away.
The largest object in space is about the size of a double-decker bus, the Mir space station, but we track pieces down to just a few centimeters. And in that area, we're talking about 10,000 objects altogether, mainly debris.
Dave Timon is an analyst whose job is to identify the more unusual objects which the radar picks up.
We'll need to be able to protect certain satellites, particularly those that are manned, to ensure that none of the debris hits them. And to do that, we need to know accurately where every piece of debris is.
But with hundreds of satellites and thousands of pieces of debris, unexpected collisions can and do occur. In 1996, a French military satellite called Ceres was following its normal orbit when it suddenly stopped transmitting.
Fylingdales got a phone call from the operators of Ceres. They told us that something had gone wrong with Ceres. They didn't know what. They tried everything without success. They wondered if we knew anything.
Ceres was not one of the satellites that his colleagues had been routinely observing on their screens, so Dave Timon was called in to work out what had happened.
We ran a simulation, if you like, of Ceres against all the other pieces of debris and all the other satellites for a 5-day period. We were looking for something that came near Ceres, and in fact we found an object that came right into Ceres. It obviously hit it.
They had collided, and the stabilizing mast which kept Ceres pointing towards Earth had been snapped off, sending the satellite tumbling through space. By remarkable coincidence, the object which had hit the satellite was a piece of a French rocket.
Ceres is a French military payload, and by a fluke it was hit by a piece of French debris that had come from an earlier French Ariane launch many years before, but was still in space.
Ceres was not totally destroyed. It continues to orbit the Earth, though its value as a spy satellite has been severely impaired. But was Ceres really the first satellite to be hit by space junk?
Cosmos 1275 was a Soviet navigation satellite that blew up in 1981. The interesting thing about Cosmos 1275 is there was really no energy source on board that should have caused this satellite to blow up into nearly 300 pieces of debris. Many people have come to the conclusion that they think it may have broke up due to a collision with another piece of orbital debris. Unfortunately, there's no way we can tell that for sure because the information that we need, such as a track on these small pieces of debris, doesn't exist.
What scientists do know is that nothing in orbit within 2,000 miles of Earth escapes being hit by small particles of debris. In less than a year, the detector panels on this satellite received over 15,000 strikes. This is the sandblasting effect of everyday exposure to the environment of space. An unlucky encounter with a larger fragment would cause far more dramatic destruction. And the risk to human beings is now causing alarm.
Pieces of debris could be so small they cannot even be seen by ground radar. And yet these pieces of debris traveling at 18,000 miles per hour can slam into our space missions, causing them to tumble, piercing the hull, causing tremendous amounts of casualties perhaps in outer space.
And that danger was highlighted on June the 11th, 1999, when a spent Russian rocket came hurtling towards the brand new International Space Station. Space Command predicted that the enormous projectile would pass within a kilometer of the station. If it hit, the station would be obliterated. Luckily, the rocket body missed the station, but it was one of the most perilous moments in recent space history. There is no way that we can clean up the tons of junk orbiting our planet. All we can do is wait for it to fall back to Earth.
Every day we observe at least one object coming back from space to Earth. These range in size from the order of a portable phone to large space stations. Normally, the objects burn up on re-entry heating and nothing survives to impact the Earth, but the larger objects we can see at least 10% surviving. It's difficult for us to predict where this 10% will impact on the Earth due to a number of factors, but mostly due to the complexity of the shape of the vehicle coming in.
As 3/4 of the Earth's surface is covered by sea, that's where most of it comes down. But not always. In the early hours of January the 24th, 1978, a Russian nuclear-powered satellite, Cosmos 954, disintegrated and fell in Canada's Northwest Territory.
Cosmos 954 contained about 100 pounds of enriched uranium, probably enough for perhaps 10 atomic bombs. It crashed into the Northwest Territories of Canada, spewed radiation to about 300 miles. And even the CIA sent Huskies and dog teams to retrieve as much of the uranium as they could.
And defunct satellites which don't fall to Earth become a major hazard in space. There are over 30 broken down satellites like Cosmos 954, all leaking a chemical coolant which is forming clouds of droplets traveling at nearly 20,000 miles per hour.
Space at that altitude is full of little liquid droplets of sodium, potassium orbiting the Earth, and that of course, even though they're liquid, when something hits you at 5 miles a second, whether it's liquid or solid, it really doesn't make any difference.
In 1979, there was widespread alarm as NASA's space station Skylab came hurtling back towards Earth, threatening to hit the city of Perth in Western Australia. Fortunately, it came down in a remote part of the country. In the spring of 2000, the biggest piece of space junk ever to come back to Earth is due to enter the planet's atmosphere. The Mir space station is so large that pieces of the spacecraft are almost certain to survive re-entry. But the experts reassure us that the chances of space junk falling on humans remain extremely small.
The chances of being actually hit by a piece of space debris are less than being hit by lightning.
January 22nd, 1997, the remains of a Delta rocket launched 9 months earlier began a spectacular re-entry over the United States. At 3 a.m., Lottie Williams was walking in the park in Tulsa, Oklahoma, when a piece of burnt material hit her on the shoulder.
Because my first instinct was that it was something from a shooting star, which meant that maybe it might be radioactive or something, you know. So I didn't want to pick it up even though I had gloves on.
Lottie was the first human being to be hit by space junk. Meanwhile, a farmer in Texas was awoken by a strange noise.
I put my hat on and walked out here, and I looked at this object that was laying there. So I walked up to the south and looked over at the highway out there, and I didn't see nothing where it fell there and rolled over here. I walked back to the north and looked up there, and I said, it didn't fall here because it would smash the grass. You know, I looked up at the sky, and I said, there's only one thing. It fell out of the sky.
When this thing hit the ground, it just hit splat, this top part crushed in, and the bottom is flattened as well, and that's why it's got this shape you see here. Just moving back towards the back end here, you'll notice a couple of things. This is a very nice area of flow back you can see of aluminum here. This is a cut that we made to, again, look at the temperature and so forth in this range. We've got some more of the rivets that are used to hold on the aluminum. And you also notice this quite prominent hole. We don't know exactly what caused that hole, but it looked like it's based on the shape of the metal, the fact that we've seen some high temperature process going on through here, that this probably occurred relatively early in the reentry.
It was 150 feet, I think it was, from the house. And when you think about it, that's pretty close for such a huge object that was supposedly been on fire as it landed. And we're just lucky we're here.
Just 20 miles away, Oliver, an Airedale Terrier, sniffed out another mysterious object.
This titanium sphere is the one that was discovered by Oliver the dog in Texas. It was used to hold pressurized gas that was used to force the fuel into the nozzle during the operation of the stage. So there are 3 other balls like this, probably in Texas, waiting to be found.
The Aerospace Corporation has acquired a collection of junk, objects which appear to have beaten the odds and survived re-entry to Earth.
We've actually cut a sample of this material and we put it in a mass spectrometer to find out what the components are and see if it really is aluminum, if there are other things in there that would be typical of the aluminum that might be used on a satellite. And that's what we're looking at now, is to try to determine those things. In the analysis that we do, we believe that we could, in fact, tell what type of satellite this came from. That would be whether it's a United States satellite or perhaps made in another country, simply because of the alloy of the aluminum would be different based on where it was made. We have certain alloys we use, others have different characteristics, and so we can use those as a way of helping us determine where this came from. One of the interesting things about this piece is this is aluminum, and aluminum is one of those that we really expect to burn up. It's a relatively low melting point material. It's something that should be gone and burned up in the atmosphere. What's significant about this piece is that it didn't, if in fact it is from a satellite. And that's one reason why we're particularly interested in this. From this type of research, we learn a number of things. First, we use this to help us understand and build our models. We have models that say, okay, these things should burn up. If we find something that doesn't burn up, it means our models are wrong. And so we use this type of hard evidence on the ground to help us refine our models so we can do a better job of predicting really what's going to happen when there is a reentry. This is important because if we're able to do that, if we want a satellite to come apart, we can build components into the satellite that will make it come apart.
But some components of a satellite are designed not to come apart. And this could have led to a real environmental disaster in South America. The Atacama Desert of northern Chile is a remote and arid place. But in November 1996, people who live in this area were surprised by unusual lights traveling across the sky.
It was 10 o'clock at night. I was standing here watering the yard when a light appeared in the west. It was very strong. It looked like a plane traveling northwest. As it came towards us, it broke up into hundreds of bright lights, which were still glowing as they vanished over the horizon.
When I got out here, it had already disintegrated, and I saw a lot of glowing particles traveling horizontally to the northeast and disappearing a few seconds later.
We stopped just outside a mining village called Sierra Gorda because we were amazed by this giant ball of fire in the sky. As it slowly came towards us, it broke up. Burning fragments started falling to earth. Bits were just dropping off it.
It was really beautiful, but I couldn't figure out what it was. I only saw this light moving across the sky. I had no idea what it was.
I've never seen anything like it. It was just incredible. I was rather frightened because I thought it might fly over us and shower us with burning fragments. It was just amazing.
What was the cause of these lights traveling across the sky in this remote area of South America? The following year, similar lights in the sky were recorded on video by a man watching a football match near Seattle. Some witnesses believed that they were seeing a UFO. But the lights in the sky were later identified as a Russian rocket stage breaking up on re-entry. 95% of such UFO sightings turn out to be re-entering space debris. In Chile too, it was no UFO, but another burning satellite re-entering Earth's atmosphere. And the shower of molten metal was not just aluminium. The spacecraft was carrying a payload of plutonium. Mars 96 had been an interplanetary probe launched from Kazakhstan. The plutonium provided energy to keep its instruments warm as it traveled into deepest space. The final stage was supposed to push the probe on its path to Mars, but it failed, and the rocket was stuck in low Earth orbit. It was only a matter of time before it would be dragged back by gravity. As Mars 96 descended over Australia, it managed to complete another half-orbit around the Earth, and according to the Russians, landed in the Pacific. Or did it?
I was able to plot the trajectory of the rocket carrying the probe. The rocket did explode near the Chilean coast, where some of it landed. But the probe itself carried on towards these mountains. The plutonium is carried in 18 canisters. Some are the size of an Nescafe can, which is painted a metallic blue. The others are smaller. They look like little film containers. The total amount of plutonium is 270 grams.
This is not the first time plutonium has been scattered by a disintegrating spacecraft.
Everyone on the planet Earth actually has a piece of plutonium in their body, compliments of NASA. In the 1960s, SNAP 9A, carrying a small amount of plutonium, vaporized in the upper atmosphere. Plutonium then dispersed over the planet Earth, and with a Geiger counter, you can pick up the debris of SNAP 9A, which is in every human on the planet Earth. So all of us have a souvenir of the space program right in our bodies, plutonium from SNAP 9A.
And liftoff of the Cassini spacecraft on a billion-mile trek to Saturn.
The largest load of plutonium ever sent into space sped around the Earth on August 17, 1999, on its way to Saturn. The space probe Cassini carries over 70 pounds of plutonium, and NASA is planning 8 more nuclear-fueled missions in the next few years. What would happen if one of these probes hit a piece of debris close to the Earth?
It's only a matter of time before one of our space probes encounters some kind of space debris in space. I say it's like Russian roulette. Sooner or later, you press the trigger often enough, and one of our space probes will in fact encounter space debris and spew plutonium on the planet Earth.
Just like nuclear contamination on Earth, there is no technology which can simply clear up the growing pollution in space. But occasionally nature provides some assistance. Every 11 years, vast clouds of plasma spew out from the sun and head towards Earth. During these sunstorms, the Earth's atmosphere expands.
As the atmosphere expands, it will become denser at higher altitudes, and this will start to bring objects back to Earth. During the last major period of sunstorms in 1991, we saw a large number of objects of the order of 1,000 to 2,000 objects come back to Earth.
Sunstorms can clear up some of the mess, but junk is being generated far more quickly than it is being burnt up, and scientists are learning to live with the risks it presents. Here at the Hypervelocity Laboratory in New Mexico, NASA scientists have designed a gun which can fire small projectiles at 7,000 miles per hour. This is far slower than most orbiting debris, but the gun helps them work out how well the spacecraft and spacesuits can cope with impacts from small meteorites and junk.
Attention all personnel in 272 area. Hazardous operation is about to commence. 272 area main floor is now in red status.
High-speed X-ray photography shows what happens when the projectile hits a conventional spacecraft. It punches a hole in the outer skin, but the impact turns the projectile into a spray of tiny particles.
There are a number of small craters that are formed on this rear surface, and there's even a small hole and a small crack in this particular example.
Small holes and cracks are exactly what you don't want in a pressurized spacecraft like the International Space Station.
This is a finite element model of the International Space Station, and in this contour plot, the red areas indicate the highest risk of impact, and the blue areas indicate the least likely areas of impact. So if you're a shielding designer for the International Space Station, you want to put your most robust shielding in the front of the spacecraft in these red areas, orange and yellow areas.
Endeavour Houston, we're ready for free drift.
To protect the space station and its crew, new kinds of shielding have been created from ceramic fiber cloth.
What we're doing in this design is giving ourselves an opportunity to shock the projectile more than once. We can shock the projectile, well, 4 times with the 4 bumpers. We've actually liquefied or vaporized all of the projectile material, and we just have a little bit of black soot from the bumpers and a slight bulge on the rear surface. But there's no failure of the rear wall. So again, we've protected the spacecraft.
But what happens if a piece of junk hits a person in space? If debris can demolish a satellite, it can make short work of an astronaut in a soft suit.
What we did was we impacted a number of samples with simulated orbital debris and meteoroid pieces to evaluate how robust the spacesuit was. And what we found in this study is that as the particles perforate each of these layers, it causes more and more damage to the layers through the thermal insulation, through the bladder material. But it takes a relatively large particle to cause this damage, about a 3 millimeter particle. And it would be very rare that we would encounter one of those particles. Astronauts are very small compared to a space station. They're going to be up there for 6 hours at a time. And so the likelihood of being impacted by a particle, a piece of orbital debris large enough to fail a suit, the likelihood is very small.
No one expects space exploration to be risk-free. But walking in space is not like crossing a busy street. Out here, you can't see grains of junk approaching at 20,000 miles an hour. And there's a lot more on the way.
Five, 4, 3, 2, 1, 0. We have ignition and liftoff of the first 5 Iridium satellites.
Commercial exploitation of space now threatens to become a major source of debris. The Iridium Corporation has recently launched scores of telecom satellites. Some have already come to grief, adding to the junk.
The Iridium spacecraft, there's more than 70 of them currently in orbit, and about 13 of them have failed in orbit. Every once in a while, one of these failures is caused by a reaction control thruster, a little jet that that spins the satellite out of control, and it becomes essentially useless.
These $30 million pieces of high-technology junk can be seen tumbling, flashing in the sky as their flailing antennae catch the sun. And now, a new constellation of nearly 300 satellites is planned for near-Earth orbit. Teledesic, a brainchild of computer magnate Bill Gates, will provide high-speed internet services worldwide. But will these commercial ventures accelerate environmental disaster? With so much more material in space, what scientists now fear is a chain reaction, a catastrophic pile-up with unstoppable clouds of wreckage smashing everything in their path.
There are predictions that as objects collide in space, they produce, say, 1,000 fragments. Each of those fragments has the potential to go on and collide with other satellites, each of those producing 1,000 fragments. So we can get a runaway situation called a cascade. This will lead to a debris belt forming around the Earth.
Cascading in a mathematical sense is occurring right now. If we continue to allow rocket bodies and payloads to accumulate in orbit, then the rate that they will grow will increase much faster than currently, and over periods of 50 years, you can have a significant increase in the fragment population. Assuming that we don't do anything to control debris and it's allowed to accumulate and increase, then the ultimate effect would, of course, eventually create a lot of small particles, and each of these small particles would collide with one another. And this is actually the same phenomena that's believed to form planets and rings around planets. And that is, when two things collide with one another, the fragments from those collisions try to go in the same direction again. You end up forming first a ring around the planet, and then eventually it would coalesce into another body.
And a new element is now entering the equation. The 400-ton International Space Station currently under construction is the largest structure ever built in Earth orbit. There has already been one near miss to the space station. An explosive impact could set off the kind of cascade that scientists fear. If nothing could be done to repair a space station hit by a large piece of junk, the astronauts might have no option but to evacuate. NASA is currently testing the X-38, a prototype escape pod, by dropping it from a B-52 bomber.
We've designed the vehicle such that the crew can get in, get the hatch closed and sealed, the system's powered up, and separate within about 3 minutes.
The X-38 would be able to glide for 700 miles in any direction. There's a good chance that if the astronauts did have to evacuate, they would get back to Earth safely. But they could be the last space travelers from Earth for many years to come. If a catastrophic breakup of the space station triggered a major cascade, vital satellites would be wiped out, manned spaceflight would be suicidal, and the fragments would eventually fall to Earth in a rain of burning metal junk. Orbiting around us would be rings of glinting debris, the shiny new bars of our planetary prison.
We have polluted the space lanes with our space debris, making it more dangerous for our children to explore outer space. That's a horrible legacy to leave to our children.